when you started the whole lesson about this whole process of GDTs, it looked a little bit daunting. A lot of stuff, a lot of symbols, and that kind of thing. However, you've come pretty far. You've got a little handle on it. How do you start to feel now? A little bit more comfortable. Not as panicky, right? So when you actually see a lot of this stuff on a set of plans, it won't freak you out, which is good because that's what it's all about. Now, you also note that you have to use, you can't just always remember all this stuff. You have to go to the resources, right? That's a key thing I want you to take with this in overall technology and work, is that you have to be good with references. No one ever wants you to try to remember everything. They want you to have the experience to know where to go to find the answers. That's a key thing in successful professional life. Now, I want to do some talking about this particular quiz and give you kind of this demonstration to kind of see how it works out for you. So let's talk about it. One of the things that was asked for is that it asks you to establish several surfaces to be datums. Now, what is a way that we establish a drawing as being a datum? How does that work? You do a little box, right? Right. So, just real quickly on the screen here. So I require that one of these surfaces be datum A. Which one is it? 7. So would you agree that I could do this right here and be good? You agree with that? No? Okay. So 7, it's got an A. What's another datum that has to be done? 6. So I can do 6. Now, here's a trick. I could have done the A down here, or I could have done the A down up here. Do they mean the same? More than likely, the designer on a real set of plans is going to do it up here versus just out on the surface. Why is that? Be easier, and there's going to be less space taken up by having one more symbol attached to something. So 6 has to be that one. So you know what they'll probably do with 6? They'll probably come out and do, what is that, B?
C.
C? Okay. So surface 6 will probably be attached to this dimension. That's kind of like a G there, but that's supposed to be a C. Will kind of look like this. What was the B? Which one's B?
1. Or no, 10.
10. All right. So I don't have a dimension down there, so I'll just attach it like this. So, yeah, I skipped a couple of the, the sequence of events, but we're going to do the datums real quick. So you all agree that I could do the datum this way, I could do the datum this way, and both of them are okay. Agreed? All right, now let's get down to some nitty-gritty. Give me one of the requirements. The first one was datum, the second one was what? All right, so surface 3 needs to be parallel to which one? 7, which we have established as what? A. So really, my feature control frame is only going to be pointed at this surface. Now, is it going to have 2 boxes or 3 boxes? 3 boxes, because you have to have that datum reference. What kind of symbol goes in here? Parallelism. And value of 2.0. Does this have a diameter in it, in here? No, because it's not a diameter zone. All right, so that's a good logical step process. We found what type we needed it to be. We went and found in our reference material what type of symbol we needed to use, and we understand whether or not we have to have a datum feature or not associated with that. All right, give me the next one. Anybody now?
Surface 6 is...
Surface 6.
No, that's a datum.
Okay.
The whole one is to be in true position.
Yeah.
With a diameter tolerance of 2.0.
Okay.
With respect to surface 7 and 6.
All right, so this one is requiring you to use a true position, but there's 2 dimensions called for, so therefore there's 2 datums you have to reference. Now, a lot of times they would actually attach this to the datum, or I'm sorry, the diameter dimension. I don't have a lot of space here, so I'm going to draw it out here. Now, how many boxes am I going to have this time?
3.
More than 3. 4, because you got 2 datum references. So we're going to have a reference to A and C. Does it actually matter which one? Not really, because letter-wise doesn't make a difference. You got to use both of them. Most people will put them in alphabetical order. It does have a diameter value here, 2.0 here, and what kind of symbol goes here? What's it look like?
parallel, or,
Circle with the, yeah, circle with a crosshair in it, and the arrowhead goes to this. Would you all agree with that? Do you agree with that feature control frame? All right. Give me another one. What else we got? Okay.
6.
So surface 1 perpendicular to 6. So I'm gonna, again, I don't have a lot of space here. So I'll throw my datum in. Datum for 6 is what letter? C. It's perpendicular, and the value is 2.0. And I'll take my feature control frame leader and point it back to that one. Now technically they would actually draw this outside the part a little more. They wouldn't like to draw across the part like this, but you get the point. I'm just running out of space. All right. Flatness tolerance on 10. So I'll just, how many boxes in my feature control frame? 2, because it doesn't reference the datum, and 2.0, and bam. Go ahead.
On the first one you did,
Okay.
with the arrow was pointing. I had the arrow pointing towards the box instead of
Oh, so your arrow did this?
yeah.
That would, well, that's incorrect, because your leader that comes out of your box is saying, this is what we're doing, and my leader has to come out and tell you to do that. I see what your logic is, though. Hey, I want this surface to mean that. I want this surface to follow these rules, but it's just how the system works. You're supposed to have the arrow coming out of the box to the surface.
I'd say it's the same towards the datum box too. It needs to be towards the part.
Yep, it's always that way. Although, like I said, I understand the logic totally, but you got to think about it this way. If we did it the opposite way, and let's say here's a feature control frame, and we start taking services and pointing them across this and this, then we run into a mess. So that's why it comes out. It doesn't come from that side ever. Comes out and goes down to the feature. That's okay. That's a learning experience. And datum references always have to be box, line, filled in zone, touching whatever you're trying to hit.
You say it always comes from the left?
Yes, the actual feature control frames, they don't ever, as far as I know, I've never seen them ever come to this side and go that way. It's sort of like that. I mean, it's just procedure. It's like welding symbols. Welding symbols only have the leader, welding symbols don't flip. Same story here. The leader coming out of the box doesn't flip. You always have the leader coming out from this side. That's why you'll see them do this little number. They'll come out and go back, out and back over themselves. You know, and the good thing is you all are not really, you know, it's not really your thing right now to be worried about how you draw them directly. It's just your ability to read them. But this is a good way to practice. Other questions on this one? All right, so again, your comfort level is increasing. The more we do this, the easier it gets, and the more you get used to using reference material, which is crucial. It's a good time for us to discuss, turn this off, us to discuss any questions that you all might have on your homework assignment. Now is a great time to ask them. Any at all?
I have a question on the,
Okay.
I couldn't get the,
So while you're thinking about that, let me give you a little brainstorming session here. So I like to do things in terms of wrong and see if you can catch them as being wrong. So if I were to do this, would you see this as doable or not? Just the straightness tolerance.
Yes.
shouldn't be a diameter, should it?
There's your catch. Tolerance-wise, yes, because we don't always have to have a datum associated with straightness. But you're not likely to see a straightness tolerance correctly shown with a diameter symbol in it, unless someone kind of really stretching what that tolerance is built for. All right. But what if I were to give you this? And let's go true position. Is this possible? But I've got 3 datums out there though. It could be. Well, in the size or the shape is important because it could be 3 dimensions, right? You could have position from the left, position from coming down, and position in terms of depth. So yeah, it is true. True position could have a multitude of datums referenced. What about the diameter symbol? You agree with that being there? It could be. Definitely, absolutely can. There's no doubt about that. So we've got some possibilities there. Let's see what else we've got. Let me think for a second. Whoa, let me do that. Go there, there, and let's go there. How about that? There we go. Can't be perpendicular. So even though I've called out A as being here, and technically all my symbology is fine, this surface can't be perpendicular to one that could be there. Now, let's say in terms of me making a mistake, what 2 mistakes could I have made to fix this? Or would have been right if I hadn't changed? There's 2 possible things that would be different.
If you would have been correct,
Yeah.
A would have been.
I could have swapped this out for parallel. What else?
You could move A to the side.
Yep. A could have been over here and therefore correct. Absolutely. So you're getting the hang of this process. Awesome. Let me try another one. Is this possible? Okay. Walk me through what I'm actually saying. And I'll label the surfaces for you. 2, 3, 4. First question. What kind of part is this? It is a cylinder. Now walk me through the rest. Well, not hole. It's a cylinder. There's no hole in it. Okay. The cylinder, what about the cylinder though? Here's the catch. It's not that. This is, when you see cylinders used in this format, that's a rare little catch they're going for. What they're actually targeting by showing this feature control frame attached to this, and they wouldn't have an arrow there, they would just have attached to it. Attached to this value is what they're really targeting is not the outside edges of the actual cylinder, they're targeting the center line. Okay? So what they're saying is the center line of this cylinder has to be perpendicular to one of its sides. Side what? What surface number is that? Well, that's the datum. What surface number on the screen? On 1. So what they're saying is the center line of the cylinder has to be perpendicular to surface 1. Well, it's some kind of base feature about it within a certain tolerance zone of 2.0. Now you'll notice that the tolerance zone is what shape? Well, what shape is that? What geometric shape does that represent? A circle, right? So you've got a tolerance zone that is cylindrical within a cylindrical thing, and what they're saying is, does this center line stay in that zone all the way up and down the part? You're dealing with a 3-dimensional control here. And that would be hard to measure, and this goes back to our whole tolerance conversation. This is hard to measure with a measuring tape, right? That's why we have this whole different system of measuring and testing with GDTs, because it's hard to say, I want a 3-dimensional zone in blue here for my center line of my overall cylinder fit within the whole way up and down. So this is something you want to watch out for, because sometimes when they attach it like this, they're not talking about the outside edges of the cylinder, they're talking about the center line. And what they would do is they would probably have the diameter of the value. Let's say the diameter of this thing is 15. They would have the diameter be attached to the measurement, but this attached to that, implying that it's the center line of the cylinder. Does that make sense? Does that work for you? That's the kind of things that you'll run into in the field that will kind of throw you off. What are they talking about, especially when dealing with cylinders? And to recap, if I see this little feature on a set of plans, or on a feature control frame, well, actually, let's just do it legitimately here. Bam, some kind of thing, 2.0 mm, or just M. What is that telling you about the feature control frame?
Most material.
It's called most material. Now, would it be different if it's a hole or cylinder? Well, I mean, that's actually a trick question. Hang on. If it's a cylinder, is the cylinder going to be big or small to meet this condition?
It's absolutely place.
If the whole,
No, we're talking about cylinder. If I'm talking about solid cylinder, is it going to be, if it's solid cylinder, is it going to be big or small for this condition to kick in?
will be big.
It's going to be big, right? Big cylinder means more material. Now, in terms of tolerance, let's say the tolerance for this cylinder was 10 plus or minus 5. Is it 15 or 5 that makes this thing kick in?
15.
It's 15. So that means when it's on the high side of the tolerance, this feature control frame, whatever it calls for, kicks in. What happens if I'm on the low side of the tolerance? Do I have to do this feature control frame? No. What I'm saying is,
So you have to check
do I have to check this feature control frame if my cylinder checks out at 5 millimeters?
it.
Well, that's what this tells you. This says you only have to check it when it meets this condition. Get what I'm saying? So if I'm at 15, you had the M in your feature control frame, yes, you need to check this.
But it can't get bigger.
Well, that's not really what they're calling for. What they're calling for is saying, hey, this is only a problem when, okay? And if there's a problem, that's when quality control steps in. So this part comes down the line and the quality control measures it at 15. They look at the feature control frame and they say, do I need to check this or not? They look at this M and they think, most material condition, got to check this. Next part comes down the line, it's at 5. They look at the feature control frame. It has an M here. Do they need to check what this control frame calls for?
No.
They do not. Now, what happens if we turned around and we switched it and it were to say this? Which one of these two do I have to check? The 5. And when I say check, I mean apply this feature control frame requirement. QC can ignore, here's what QC can ignore. They can totally ignore this thing if it comes in at 15, now that I have the L here, but they have to check it when it comes in at 5. Is that making sense? That's what these modifiers are here for. They're to say when or when you don't have to worry yourself with this. Because again, the more feature control frames, the more quality control, what's that do to the price of the part? More. The more you have to quality control, the more you have to check, the more it costs to do this part. So always understand, when you see this modifier, that means that you may have a way out of having to do the project or doing that task based on that. Now, like we said though, that was a cylinder. Now I've got a hole. And I see a feature control frame, and here's my values. Part A has a diameter of 15. Part B that came down after it has a diameter of 5. We'll assume the same tolerance as the last one. My feature control frame says this. Let's say it says 2.0 L. Which condition, which part, A or B, do I have to check? Do I have to apply what this feature control frame says? A or B? Got a B? Anybody got an A? Everybody going to abstain from choice? All right, let's do the logic. Here we go. First off, we're dealing with a hole. What makes an L least material condition on a hole? A big hole or a small hole?
Big.
All right, a big hole results in less material, right? Everybody agree with that? Big hole means less material, so that means less material condition. So the question is, knowing that, which one of these two parts, A or B, represent the version where it is in the L situation? A, because the hole is big, right? We need to switch from cylinders, yes. This is a hole now. So A is big, the hole is big, so therefore there's least material condition. So on part A, do I have to check this feature control frame? Yes, I do. Part B, it comes along, I look at that diameter, and I say, well, that actually is a small hole, so that will be the equivalent of M. M is not in this box, so therefore, I don't check. Are we hanging in there? All right, so obviously on the job, this is something you would take your time and really thinking through. You would make a rash decision and something like this, but that's how some of the logic works. That's what these modifiers do, is they sometimes can give you an out based on the tolerance measurement. Questions on that? All right, take a look at this one. So this one's tricky because I've applied several things, but here's your scenario. You're dealing with a part that is a cylinder with a hole right down the middle of it. The hole itself, of course, is also cylindrical. So take a look at my feature control frame, take a look at my situation that I have listed here, and tell me, is this possible? Well, while you're thinking about it, let's break it down together. First off, what am I testing, the cylinder or the hole? I'm testing the hole. How do I know that? Well, not all the arrows. The feature control frame arrow does definitely point to it, right? So that's what we're testing. Now, what is being used as the datum? Which is, in terms of the part, what is that? The cylinder. So we're testing the hole with respect to the cylinder, agreed? Okay. How do we know that? Well, that's because this datum is attached to the diameter of the cylinder. And the hole is referencing the A, which means it's referencing the cylinder. Next question, what am I testing? Yeah, we're basically lining up concentric holes. Anyway, you're basically dealing with two cylinders, one with respect to the other. The datum one, the one that we're using for reference, is the big one. We're testing the hole, and can anybody describe to me what concentricity is all about? Yep.
It's the centering of the two cylinders.
Yeah.
I was going to ask, so according to what you're saying, the outer diameter of this cylinder is acting as if it were a big cylinder and a small cylinder. As they show in the diagram here, a big cylinder and a small cylinder.
Well, no, you're not. You got to keep in mind, you're not actually dealing with two. You're describing two cylinders. But that's not what's happening here. What you're having is you have one cylinder that has a hole in it, and that hole is cylindrical, yes, but it'll be confusing if you think of it as two cylinders. It's not two cylinders.
Well, yeah, not two.
Yeah.
The diagram shows a two-stage.
That's right. Okay, so and it doesn't have. It can be multiple parts or it can be a single part. This is a single part example of yes. We are concentric, which is, you said it really well, it's actually basically similar cylinders. But you have to have one be the dominant one. You have to have one be the basis. So we've established that the big cylinder is the basis, the hole going through it is the one being tested, and my tolerance zone is what value? 2. So what we're saying is, okay, here you've got this cylinder with a hole in it. I want this hole to be concentric to the big cylinder within a diameter zone of 2.0. So if I were to draw this zone of tolerance, it'd be that big, goes all the way through the part, and as long as the center line for my hole stays within that zone, I'm good. Let me show you what it really looks like. Here, let's imagine our cylinder, and here's our hole. You can see that my hole got a little bit sideways, right? Here is the center line for the cylinder. So I've got the hole's center line, I've got the center line for the cylinder, and let's say the zone, and I'll just draw it real quickly in red, is this big. Value of 2, right? That's how big that zone is. Do I pass?
No.
I do not pass. That's what concentricity is all about. You take basically the center line of one cylinder and compare it to the other. The one in question that's used as the reference is the big one. The hole is out of whack. This controls people from basically drilling sideways or getting some kind of curvature or something. This can also be replaced with someone actually using a true position. A true position geometric tolerance can almost accomplish the same thing for this particular scenario. Okay? They can do it by saying, all right, I want you within true position all the way up and down the part within a tolerance of 2. So concentricity can work here, and true position can work here. All right, does that make sense? Yep.
Can the true position just come from one end, or would it have to be from both?
That's an excellent question. How does the true position work? Well, let's look at it this way. Here is our cylinder, and here is our hole. Now, true position is usually based on dimensions or features. But let's just say we can honestly assume that if I were to measure from the tip of my cylinder to the center of my hole, I could have measurements, right? Now, I mean, we just assume it's supposed to be in the cylinder, but you could also measure it correctly, or correct? Yeah, you could. So, if I turn around and say, okay, true position of that feature, and I also have a dimension right here, and I call, let's say this is datum surface A, and I'm going to run out of boxes, but you're going to get the idea. I can establish that my true position zone, I'm going to draw it in blue, goes from one surface to the other all the way up and down. The fact that I have those 3 boxes at the end means that I'm accounting for this way, and then this way. So a person could start off at the top, apply a true position, and have it account for all the way up and down the cylinder. Now, would it be easier for them just to use a concentricity GDT? Absolutely. But you at least see that the possibility is that you can actually cross over and accomplish the same thing with different stuff. Okay? Yep.
And the reason I ask that, of course, is you could mark that on this end and hit your target on this end, but if for some reason that is turned a little, your drill bit's going to be...
That's absolutely true. You could actually hit it on one side, and if it didn't have that third dimension to it, to say check all the way up and down, you could be doing this, and it'd still be passing. That's why they would probably have to throw in that third reference to establish that third dimension all the way up and down. Okay. Questions on that? All right, that's a good pause point. Stop there.